Before an army can fight, it has to move. But in the ancient world, movement is strictly governed by the earth itself. A simple dirt track turns into a physical barrier the moment a supply cart sinks to its axle. Add a weather variable like rain, and the kinetic energy of a marching column dissipates entirely. Thousands of pounds of heavy iron armor and weaponry become a liability when the ground turns to sludge. Military theorists refer to this natural resistance as environmental friction. It is the physical drag coefficient applied by the landscape to any moving force. Before the Roman military engineered a solution, a commander could never accurately calculate deployment times. A march that took 10 days in summer could take 40 days in the winter. As long as environmental friction dictated velocity, relying on natural terrain remained a strict mathematical vulnerability for any expanding military force. The Roman Empire ultimately governed a quarter of the human population across a territory spanning a ninth of the Earth's circumference over 3 continents. This immense scale created a strategic paradox. A centralized state cannot maintain control if insurgents 300 miles away can succeed simply because seasonal mud delays the responding legions. This diagram illustrates that exact problem. A military crisis unfolds rapidly. If the response vector relies on an overland march over unpaved dirt, the arrival time fluctuates wildly based on rain or snow. The other vector represents a response moving at a fixed, constant speed. The Roman military recognized a harsh logistical reality. They could not negotiate with the landscape to solve this timing discrepancy. To guarantee a predictable rate of military movement, they determined it was necessary to permanently pave over nature itself. The viae publicae were a pure military asset, designed, funded, and executed entirely by the Roman legions. To minimize distance and maximize deployment speed, the military demanded routes that traveled in perfectly straight lines. Topographical obstacles like swamps, hills, and forests were treated as mathematical errors in the route. Rather than navigating around them, engineers corrected these errors through brute force excavation and aggressive bridge building. To project these straight vectors over the horizon, surveyors relied on a specific instrument called the Groma. By aligning the hanging plumb bobs, engineers used the Groma to enforce rigid perpendicular grids and linear paths, entirely ignoring the natural curvature and contours of the terrain. Roman road routing was an exercise in pure geometric dominance. They actively bypassed the path of least resistance to ensure the shortest possible deployment time for their troops. Looking at this cross-section of the construction process, we can see that building the roadbed required digging deep into the earth before building up. Engineers started by carving 2 parallel boundary trenches, or sulci, spaced precisely 15 feet apart. The loose earth between these trenches was then completely excavated, digging down until the workers hit a solid foundation base, a compacted bedrock layer known as the gremium. If the ground was marshy and lacked this solid base, engineers artificially forced stability by driving heavy wooden piles deep into the mud. Into this empty trench, large, fist-sized raw stones were packed tightly to provide heavy structural base weight. This heavy foundational course is defined as the statumen. Because of the coarse gaps between the raw stones, the statumen ensured that subterranean water could drain away without washing out the upper layers. This effectively neutralized ground-level environmental friction. Returning to our cross-section, the road also needed to absorb the repetitive kinetic shock of tens of thousands of heavy infantrymen marching over it for decades. To solve this, workers poured and violently rammed down a thick 9-inch layer of rubble mixed with lime cement. This shock-absorbing slab is identified as the rudis. Next came the nucleus, an additional 6-inch layer composed of finer crushed brick and pottery shards mixed with lime cement. This formed a perfectly smooth, binding bed for the surface. The final, highly visible surface layer was explicitly engineered to withstand the grinding wear of iron hobnailed military boots. This surface is the pavimentum, formed from hard basaltic lava blocks cut into irregular polygons and fitted tightly together. The pavimentum was intentionally crowned in the center, creating a raised profile called the ager viae. This slope ensured that rainwater instantly shed off the sides and into the drainage ditches. This complete stratigraphy was a chemically bound, waterproof machine, a multi-layered system designed to isolate the Roman military from the friction of the natural earth. The Roman state replicated this intense microengineering process across more than 80,000 kilometers of the known world. This map, plotting travel times, shows the output of that engineering. It allowed legions to achieve a rapid military march velocity of 60 kilometers per day. Moving along this continuous line, a force could deploy from Rome to Londinium in exactly 27 days. By achieving a fixed, weather-independent rate of travel, the Roman military effectively shrank the geography of the empire. Rome's non-standardized adversaries, forced to march on unpaved dirt, remained fragmented and entirely dependent on seasonal weather conditions. Geospatial dominance is achieved through infrastructure, building the capacity to move forces faster than an adversary can react. There is a modern misconception that these highways were built to facilitate peaceful commerce, trade, or cultural exchange. The engineering proves otherwise. For an unsprung wooden commercial ox cart, the hard, stepped basalt surface of the viae publicae was highly inefficient, causing severe structural damage over long distances. Instead, this unyielding basalt surface was perfectly engineered and optimized for one specific entity, the Roman heavy infantrymen. Once a territory was conquered, the construction of the road through its center ensured the region could never successfully isolate itself from Roman retribution again. The Roman road network was an inescapable grid. It was a permanent, physical tether that weaponized the landscape and locked the ancient world into a state of guaranteed kinetic response.